Hello guys, nice to meet you once again. So in the last video, I think I had discussed in detail about the main devices, lift devices, control surfaces, the main functions of the parts of the aircraft in detail. So by now, I think you have some basic knowledge about the aircraft, how an aircraft flies and such other things. So here I will get you through the procedure of designing an RC aircraft, the main components inside it, the electronics of an RC aircraft, and the model selection of RC planes for beginners. So let's begin and go ahead. So RC planes for beginners. So RC planes are nothing but a hobby related part. Usually children like to enjoy this, play with this, because it gives a lot of fun. Even I enjoy RC flying, and I have got some experience in RC flying. So to begin with, you always need to practice with simulators. You can get it in the market by on CDs, or you can download it from net or anything. But you need to have a good knowledge of the radio control, the simulation part of it. Only then you need to begin with flying a real aircraft model in environment. Okay, so the simulators which I suggest is Real Flight G5, Aerofly Professional, Phoenix RC. Also there are many other simulators. You can go through anyone which is of your wish. Okay, so imagine that you have already learned simulation part of it. Now let's get in through the model, quickly look at some of the models which are used as beginners. Okay, so this model is a basic model which is always used by a beginner. It's a Cessna model. You can also have another model same as this with small difference, such as Blazer. So these provide very high amount of stability since high wing with a small amount of diagonal. So usually the features of this aircraft are, it's a high wing aircraft. The airfoil is a thick airfoil with a flat bottom, serving the purpose of high lift at low speed. It has got nice lift characteristics, a slow landing speed, less landing speed without stalling. It has got a dihedral of 5 or 6 degrees. It's provide lateral stability. Also it has a rectangular wing platform when you look at from the top. High aspect ratio, very long wings. Okay, so in the last video we had already discussed the main parts of the real aircraft. So when you compare the real aircraft with the model flying aircraft, all of the parts, the basic parts like control surfaces, wing, fuselage, stabilizers, vertical fin, everything remains to be same, but only some of the components you'll find a change when you compare with the trainer model, hobby model with the real-time flying aircraft. So all these aileron, stabilizer, fuselage, fin, rudder, elevator, landing gear, or all remains to be the same. And okay, this one of the device or thing that makes it different from a real aircraft. It's an engine. So engine for RC aircraft, it can be a two-stroke engine, muffler engine, or also an electric brushless motor can be used. So in our model we had used brushless motor. You can also use engine with a throttle control on it, but the disadvantage is that you need much more fuel compared to electricity. So electricity can be easily it's easily got, or it's easily available. So I prefer you always go with a using brushless motor for powering or propelling the aircraft. So radio control. So before flying an aircraft model, what you need to have a brief knowledge about is radio control. So this is a apropos radio control which we have used in our labs, and this is a receiver corresponding to this transmitter. It's RJ631B. It's usually a long range receiver with a DMSS component. Also you have a short range within with 600-700 meters range. You have one more kind of receiver called RG611B. You can choose either of the both. So this apropos, it's a 6-channel radios. Here it has been a mistake, sorry for that. It's a 6-channel radio. This model is apropos XG6. So you can get this at around 3,000 to 4,000 rupees, around that. I don't know clearly, maybe around that. Okay, so this is the transmitter antenna, radio transmitter antenna. So radio signals and transmitted through this antenna stick, and it is received by the receiver antenna. So these wires which you see here are the receiver antenna, and this is the receiver, and these are the output pins of the receiver. So these are the control sticks and the control horns, switches, which gives it a function, which enables it to function as a 6-channel radio. So these two control channels which are here give 4-channel controllability, and these two switches or control sticks, additional 2 control sticks, give extend the channel by 2, giving a 6-channel controllability. Okay, so here is a basic layout or schematic of simple radio transmitter. So this is the aerial which we already discussed. Also it has a handle to carry it out around. So here it's a 5-channel radio. Okay, so these are 2 control sticks. In addition to that, we have only 1 control switch instead of 2 which we have seen in this apropos. So here it's only 5 channels. So the channel 1 is the aileron. So this motion causes channel 1 to change. Usually ailerons which are used for rolling of the aircraft. And channel 2 is the elevator. The to and from motion towards and away from you gives aircraft a motion of pitch, nose up or down. So the channel 3 is a throttle which is used to increase the propelling force or the thrust of the aircraft by changing the propeller speed. And the channel 4 is the radar, which is the left or right movement of the left control stick in the transmitter. So it causes the horizontal rotation to right or left, causes yawing moment in the aircraft. So the additional control stick can be used for many purposes, such as landing gear. You can also use it for an extension of flaps. So if you use it for landing gear, the landing gears can be deployed or extended after the takeoff. So these are some of the trimming switches. These are trimming switches for channel 3, channel 4, channel 2, channel 1. You can trim various control surfaces to balance the aircraft, and you also have some additional switch. You also have got a display here. This will be a display. So in this gyro transmitter, you can see the display, and you also have some mode switches, select switches, return switches, back switches, power switches, which are used to change some settings like some trim, mix, or model select, like fixed wing aircraft or helicopter. All this can be changed using this display. Okay, so the next main part of the RC aircraft is electronic wiring. So electric system of an RC aircraft consists of battery, receiver, electronic speed controller ESC, motor, which is a brushless one, servos, connecting wires, and some connectors such as bullet connectors, banana connectors, T connectors, and such others. So the first one was battery. So usually we use LiPo battery. These are specially meant for flying purposes. They can be easily charged. Also, they discharge very soon, which is another disadvantage. So this is a T connector. So this end portion, the red thing which you can see here, is a T connector, which is used to connect this battery to ESC. So these are some other connectors. A banana connector used to link different wires. So this is an ESC. So ESC has different ratings. So the rating should be matched with the one with the battery. So here we have 3350 mAh battery with 7.4 volts. The battery may be either 3 cell or 2 cell. So we have used in our model a 3 cell battery, which is 11.3 volt. I think this 2 cell battery with 7.4 volt. So the function of electronic speed controller is to provide a 3-phase signal for the brushless motor, because on the brushless motor, unlike our usual DC or AC motor, we don't have any brushes to change the direction of flow of current in the motor to cause it rotate, to make it rotate continuously. So unlike that, if we don't have brushes which is in contact with the motor commutator, we need to provide commutations or change in the direction of flow of signal using these 3-phase wires with these 3 wires. So electronic circuitry in this ESC speed controller provides it serves for that purpose. And also another main function is it can also change the speed by changing the amount of current flow through these wires. So the thrust of the aircraft can be varied by using the aircraft's electronic speed controller. So these 2 wires, this goes to the battery. You can use the T connector here, connect these wires to the battery here, and this goes to the 3 pins of the motor. So these the golden color pins or the connectors are called bullet connectors. So you are meant to have a female bullet connector on these wires. You can connect the ESC to this motor and this part of ESC to the battery. So here I think it's a Exceed RC rocket, what is a brushless outer runner motor. So the term outer runner motor means that the outer part of the motor, so this part of the motor, the casing of the motor, is the one which rotates, unlike our DC motor wherein only the shaft rotates. So only the base of this motor is stationary, and all parts of this motor rotates. So since it's an outer runner motor, it provides much more torque than compared to the motor wherein only the shaft rotates. Also, the brushless feature of this motor helps it to avoid some of the contact problems at very high speeds, such as sparks coming out of the motor, etc. So these are some of the accessories which come along with the motor when you buy it. So these are used to fix the motor to the base saw. You also have some prop spinners along with it, and some screws and other stationary parts. Okay. Another the main thing without which an aircraft cannot move is the propeller. So the propeller has got different dimensions and different pitch angles. The one which we used in our model were 9x6, 9x4.5. Okay, I think 9x6 is here. So this 9, the first term indicates the dimension, the diameter, like so this 9-inch, I think this 9-inch, so 9x6e. So 6e, it's nothing but the pitch angle. You know that the propeller is slightly bent in either direction. There's some angle on either leaves of the propeller, either blades of the propeller. So those pitch angles are depicted by these numbers 5e, 6e, 7e, 5.5e. So other things, these are high torque servos which are used to control orientation of control surface, such as flaps, ailerons, rudders, or elevators, or landing gear. So servos also have 3 wire inputs. The central one is for the signal controlling the rotation of the servos, and the other 2 on the either side will be a positive and negative wire, which are usually connected to plus 5 volt and ground. So here you can see the 3 wires of the servo. And servo is nothing but a combination of DC motors with a number of gears and a potentiometer inside it, so that it provides a closed looped feedback to know the error detection, to form the error detection circuitry. Okay. So these are the JR proper receiver components. So you have a receiver with DMSS, long range antenna. So these are the antenna wires which you need to keep out of the aircraft model, so that it is clearly in line with the transmitter antenna. These are the binding plugs which are used to bind the transmitter and receiver. So binding means to set the frequency of communication between the transmitter and the receiver. So before using the model for the first time, you need to bind the receiver and transmitter using this binding plug, and corresponding binding settings using the transmitter. Okay, so this is the important wiring, or main wiring which you need to construct for an RC aircraft. So let's begin with the battery pack. So we have a LiPo battery here, maybe 11.3 volt, 7.4 volt. Okay, from the battery, as I told earlier, you have any connectors such as banana connectors or T connectors. What we use was T connector. So you have T connectors, but make sure that before connecting you have the right polarity between ESC and the battery pack. That is, the polarity should be matched, red to red and black to black. Red is positive and black is negative. If you interchange, then you will have to spend some money for the ESC again, so be careful with that. So this is a fuse which is connected to protect the ESC, but it's not mandatory if you are careful, or else you always need a fuse. But we had not used any fuse because we were always cautious about the voltage on current rating of the battery and the corresponding current rating of the ESC. Also, these are arming switches which are of no importance. You can use it or either leave it. So from the ESC, let me explain you about the wiring of the ESC. The ESC will have so many inputs and outputs. So it has two wire input from which is to be connected to the battery, other three channel inputs for the motor. So these three wires are to be connected to the corresponding three wires of the motor. So the point may be noted that if you connect these three wires, and once you arm the system and you get the motor rotating in some particular direction which is not required by you, and you need it to rotate in opposite direction, then you need to just make some small difference, that remove any of the two wires, interchange any of the two wires, and leave the third wire as it is, interchange two wires and fix it again, and once again you arm it. You see that the motor rotates in opposite directions. Receiver also has some input from the receiver, which is usually connected to the throttle channel of the receiver. It's a 3-pin connector that you use. So you can to change the speed of the motor, you always have to input some signal to the central wire from the receiver. According to the signal received, the digital signal PWM signal received, the ESC electronic speed controller varies the speed of the motor. Okay, so this circuit was for brushless motor. For brush motor, you'll have only two wires, so that's one of the changes, small change to be noted. Okay, so it's both the same circuit diagram, but here they have explicitly mentioned some additional servo connections to the receiver. So the receiver will also have channels such as throttle, aileron, elevator, maybe landing gear, rudder, auxiliary 1, auxiliary 2, battery, etc., which is explicitly mentioned on the receiver pins. So you need to connect the corresponding servos of the control surface to the corresponding channels properly, and also before flying the model you need to check with all the servos and the control surface by moving them using the transmitter. So here it's a BEC. BEC is nothing but battery eliminator circuit. So usually all ESC will have a BEC. Almost ESC will have a BEC which is usually installed within it, so that you need not use any external BEC or battery pack to power the receiver, unlike in this particular connection. So here they have used a 4.8 volt battery to power up the receiver, but if you have a BSC inside the ESC, what you need to do is just connect the ESC to the receiver using the throttle channel. So the T symbolizes throttle channel. So the ESC provides voltage from this battery pack. So the voltage from this battery pack will be channeled to the ESC, and the ESC will extract some 5 volt and sends it to the receiver, thus powering up the receiver, and you need not require any external battery for that. Therefore I always prefer using ESC with a BEC. Note the specification when you buy any ESC. Okay, so these are the wiring diagram once again with actual component diagrams. So this is an ESC, this is battery pack which is connected to ESC. From ESC you have a throttle pin to the receiver. From receiver you have connected the servos. Also these are receiver antenna, the white color wires. Also you have a switch. Also you have a charging connector to charge the battery. Okay, so let's move on quickly to some of the gallery pics. So here you can see a glider soaring at a height which uses T-tail stabilizers, very long wingspan with high aspect ratio, and also the winglets to provide high lift. So this is a winglet of an aircraft, a commercial jet aircraft. So it's a fighter aircraft with another short wingspan, a wing configuration with leading edge root. These are leading edge root extensions is a found. So this is a passenger aircraft with with flaps and slat deployed. Here it's a Concorde aircraft with the nose drooping. So nose drooping is nothing but the pointing of nose down to increase the visibility of pilot, which is usually a main feature of British Concorde aircraft. So it's a Globemaster T-tail configuration here. Okay, so this is a nitro engine, a gasoline engine, two-stroke engine, which is used for providing thrust in an RC aircraft. Usually this kind of engines are usually used for a little bigger model with an aspect ratio of minimum 1 meter or 1.5 meter. Usually on smaller aircrafts you don't use this because of their weight. They provide weight at least some 100 to 200 or 300 grams. So you usually use brushless motor for powering up small aircrafts. Okay, that's all. Thank you for watching the video. I think you have got some knowledge about RC aircraft. I prefer that you use this knowledge, put it into your design, and you fly the model. And that's all for the day. Thank you. Meet you again in some other video. Bye.